So now we get to move into everybody's favorite, the reading computer output problems, which in many ways are going to be similar to what you're going to have on your exams and finals and stuff like that. So many baseball fans hold that because of the designated hitter rule, there are more runs scored in the American League than in the National League. A researcher for ESPN gathers data on the number of runs scored per games, RPG, on a random sample of American League teams and a random sample of National League teams for the 2006 regular season. The researcher first gives this graph and the output. Why is this important? So you can only conduct hypothesis tests for this particular for means when you have independent sampling, if you know that the data are normally distributed, right? So you need these graphs because you don't know that the data was normally distributed to begin with. It wasn't stated in the problem anywhere, and your sample size is small, smaller than 30. So if the sample size is smaller than 30 for both teams and you don't know that it's normal, then you have to prove that it's normal enough with these probability plots. Now these plots do show us that the data were normal, so we are okay for conducting hypothesis tests. All right, so now we've got our outputs, and I've circled a whole bunch of stuff in here because we'll refer back to it. So the first thing we need to know is how many American League teams were sampled. So let me put that there. Oops, hold on one second. And just FYI, accidentally I had some poor questions here. I had questions about the National League. So if you have those old notes, just kind of scratch off the questions I asked there and put in these ones instead. So how many American League teams were sampled? That's 6. You can see right here in the Minitab output. Minitab is a little bit better actually in this particular instance for output because it gives more information about each of the individual groups, if you will. So the American League had a sample size of n and had a mean of 5.185 and a standard deviation of 0.339, which are the next two questions I ask, 5.185 and 0.339. And then this is the question I want to ask, which is what does StatCrunch state as the degrees of freedom, which is 9.966 right here, degrees of freedom. I'll highlight it in yellow. So there it is. And then Minitab says it's 9. So I wanted you to notice that they're not always the same. The two computer programs don't always agree necessarily on what the degrees of freedom are. It has to do with different formulas and different assumptions that are made when these computer programs conduct these tests. So suffice to say that they're both a little bit different from each other, but they're both more accurate than our by hand method, which would have been take the smaller of n1 minus 1 and n2 minus 1, which would have been 5 and 5. So 5 degrees of freedom for the way we would have done it by hand. But we're not going to do that because we don't need to. We have the computer programs right here giving us kind of the more formal degrees of freedom, each in their own way, but they're slightly different from each other. All right, so then what was the average RPG difference? That was 0.253. I circled it in red. You can see it. 0.253, 0.253 right there. And then now the problem states that many baseball fans hold that because of the designated hitter rule, there are more runs scored in the American League than in the National League. Which hypotheses is this referring to? Okay, so Group 1 was American, Group 2 was National. So if you're saying Group 1, Group American, is greater than Group National, that's Group 1 is greater than Group 2, which means this blue one right here is the one we want. And if you look back up in the instructions, or up here in the computer outputs, you can see it. Group 1 greater than Group 1 greater than. See the verses right there? It's kind of hard to read in the Minitab output, but it's versus greater than. That's the alternative. Equal 0 is the null. Versus greater than is the alternative. All right, so then the computers don't really use what we do. So what I just circled up here in blue for letter H, that's really what you do when you do it by hand, or if you had a TI-83 calculator. They also treat the hypotheses this way, with mu1 equal to mu2 and so on. But Minitab and StatCrunch do a subtraction thing where they take mu1 greater than mu2, which was our alternative right here, and then you subtract mu2 from both sides. That gives you mu1 minus mu2 is greater than 0, because mu2 take away mu2 would be 0. So they're the same hypotheses, they're just written differently. So that's okay. Now, what if we had done the opposite? What if we had reversed it so it was National League minus American League? Then how would the null and alternative would change? Well, the null wouldn't really change that much. So the null wouldn't change, really. But the alternative would reverse, right? So it was a greater than 0, but it'll become a less than 0. Because you'll say mu2 is greater than mu1. You'll subtract mu1 from both sides this time. Mu2 is less than mu1, sorry. Because we said the National League was less than the American League. So when you subtract mu1, you'll get less than. Right? So it'll turn it from a right-tailed test to a left-tailed test, in other words. All right. Now our test statistic is 1.33 and our p-value is 0.108. I circled them in green and purple respectively. So you can see them up here. Test statistic 1.33, 1.33, p-value. Now notice the p-values are slightly different from each other. Again, these two programs are working just a tiny bit different from each other. They have some slightly different formulations, but it's close enough. It's fine. 0.1087, whichever one you want to go with. Either way, we are totally not going to reject, but we'll figure that out in a second. Okay, so first thing we got to do is make our p-value picture. So, oh, and this isn't good. This is a two-tailed test, right? Oh, no, it was a right-tailed test. Okay, so we're good. We've got a right-tailed test. 1.33 is the test statistic. The p-value was 0.108. Right? 106, 107, somewhere in there, right? So Minitab thinks it's 1.1081. And then where do we go from there? Make sure you shade right to the right because it's a right-tailed test. And I know you don't have computer programs to do this. You're just going to have to draw this picture by hand. That is not statistically significant result because the p-value is 0.108, and that's bigger than alpha. So we would not reject the null hypothesis, so therefore it's not significant. Now, if the researchers set alpha to be 0.05, what conclusion would be reached? There is not enough evidence to support the claim that the National League has more runs than the American League, right? So there's not enough evidence because we did not reject the null hypothesis. And again, we did that because our p-value is quite large. It was bigger than our alpha. All right, done with that one. Let's move on to the confidence intervals. So we're going to find the confidence intervals regarding the difference of two independent means. And again, the real degrees of freedom formula is this god-awful, horrible thing. We're not going to do that because that's just terrible. So we're going to use kind of a cheat on our confidence interval formula a little bit. So for the confidence intervals, this is for the body temperature data that we were working with before. It was the difference in the women and men. So let's just recall. Group 1 was females, I believe. Group 1 equals female. Group 2 equals male. So when we subtract x1 bar minus x2 bar, it's really the mean for the females minus the mean for the males. And we had those values given to us in a table back a few pages right here. So they're the values that I'm using. Hold on, getting down to it. There it is. Okay, so 98.394 and 98.105. Then we have 0.743, 0.699, all that good stuff. Now, how do I get these results? So that seems kind of crazy. So you get them from StatCrunch. You can go to StatCrunch. Hold on. Go to Stat. Go to T-Statistics. And again, okay, one sample T-Statistics, that was chapter 9 or 10, depending on whether you're making a confidence interval or hypothesis test for the mean. Paired was what we did in 11.2. That's when you have dependent samples like a pre-test and a post-test thing. And right now what we're doing is 2 sample. And we didn't have data because we weren't given columns of data for the men and women's body temperatures. We've got summary again. And we got to type in all these numbers. So hold on one second. There they are, 98.394, 0.743, and so on. Click Next. Now we're not doing a hypothesis test. We're doing a confidence interval. So click on that. Confidence interval. Our confidence level was 0.95. So 0.95 will work for that. Next. And we can just click calculate. And oops, there it is. So we've got this. Let's copy and paste it in. This was 11.2 example 4, excuse me, 11.3 example 4. So 11.3 example 4. And I'll just paste it in. And there's the confidence interval right there. You can see the degrees of freedom is 127. It's pretty out of control. It's that big, huge honk-on formula thing that we're not dealing with. So there they are. There we go. So, and I think I typed this wrong when I did this in the other sheet. So, yeah, I totally typed it wrong. I don't know what I was doing there. So it's between, oopsie, down here, the confidence interval is from 0.0386, comma, 0.5394. There we go. I don't know what I was doing. Alrighty then. So we've got all our pieces. And now where did I get the 2 from for that formula? So for the t alpha over 2. Well, we, of course, know how to find that because we have Excel at our disposal. Actually, we have StatCrunch at our disposal. We could do it that way. But even when we do, we're kind of cheating ourselves a little bit, right? So you go to Stat, you go to Calculators, you pick the T, and you say, okay, I want the degrees of freedom, and this is where we're cheating. We say, oh, 64, right? Because of the way our instructor, our book author set it up, he set it up so that you pick the smaller of n1 minus 1 and n2 minus 1. That's not really accurate, like I said before, but we're just going to go with it. So we say, okay, I want 64 degrees of freedom. I want my probability to be alpha over 2, which is 0.025. Click compute, and it tells us that it's about 2, negative 1.999. Okay? So that's where that came from in the actual substitution formula. If you're using the table, which we've often used, let me grab a table. Hold on. All right, so here's the t-table. Remember, you don't have to write this on a note sheet or anything. It's just given to you at your exams. So you can see the best you can do on this thing is the 2 right there. Because you take the 0.025 column, 64 degrees of freedom is not really in here. So you're going to have to go with what they give you, the closest thing, which for our purposes is 60. That's fine. So we'll just use 60. All right, so, and again, I know that's fudging it because you and I do not want to deal with this. That's what it really is, and that's a giant, giant pain. So we're not going to deal with that. So we're just going to kind of fudge it around and say, oh, it's close enough, it's 2. So our degrees of freedom was 64. It's not what it really is, but it's what we're going to make it. And then there's our formula. All right, done with that. We don't have time to finish the next question, so I'm going to stop this video right here, and we'll pick up with reading the computer output for that confidence interval in the next one. See you then.